Hello there, nerdy Nawg-Dawgs. Thanks for tuning in for your Chapter 2 study guide. We're talking about number theory, estimation by rounding, factors, and multiples. So here we go, friends. If asked, which is the closest estimate of 54 times 36? Again, if it's asking for an estimate and it doesn't tell us where to round to, we round to the highest place column. And in this case, if we're looking at the number 54, we're rounding to what we consider the tens column. Everyone considers it actually the tens column. And to do that, we know that anything to the right of this digit is going to zero out. But the question is, are we staying on the floor or climbing the vine? So we look to the digit to the right of the rounding digit. In this case, it's a 4. We know 0 to 4, it tells our rounding digit to stay on the floor. And this will stay at 50. What does that mean exactly? Well, if we think about it on a number line, if I'm rounding 54 and I'm rounding to the tens column, I know that I can stay on the floor at 50. Or I can climb the vine moving up to 60. And so you can always ask yourself or start to visualize this in your head. What's right in between 50 and 60? Well, 55. And then if we had to plot 54, it would be right about here. So is it past the halfway mark? Heck no. Therefore, it stays on the floor at 50. Everything else zeroes out, which means this rounds down to 50. So then when looking at 36, we round to the highest place column. In this case, again, it's the tens column. We look to the digit to the right. 0 to 4, stay on the floor. 5 to 9, climb the vine. That means this guy is changing our rounding column, and it's climbing the vine to the next digit, and that would be a 4. Everything to the right zeroes out. So 36, if we thought about it on the number line, is closer to 40 than it is to 30. So when looking at my options of answers, I would say 54 times 36. If I were going to estimate this, the closest estimate is then 50 times 40. Okay? So remember that with the rounding. If it doesn't tell you where to round, you round to the highest place column. Okay, next question. What is the sum of the first two multiples of 6? Now, we always have to identify what exactly is being asked. Key word here is sum. You guys know this by looking at the tools on the wall, that sum means the answer to an addition problem. And when we're talking about the first two multiples of 6, well, if you use your tools on the wall, again, multiples we can think of as skip counting. What numbers will 6 multiply into? So if I were to list all the multiples of 6, it would be 6, skip count, 12, 18, 24, 30, and I could go on and on. Now what it's asking for is what is the sum, meaning the answer to an addition problem, of the first two multiples of 6. Okay? In this case, the first two multiples are 6 and 12. Now remember, when it says the first multiple of a number is always the number itself. Okay? So in this case, it's asking us to add 6 plus 12, and we should know that 6 plus 12 would then equal 18. Okay? So make sure you're reading the instructions clearly. What is the sum of the first two multiples of 6? Well, it is 18. Okay. Next question, very similar to something on the test. Find the product of 375 times 6. Then it says estimate to check your work. Okay, this is where you have to be careful because I always seem to have some little stinker who either just estimates or does the work itself. In this case, you have to do both. So to find the product, we know we actually have to do the full math problem. So 375 times 6. would be 2,250 if you can read my writing. Now, if I were supposed to estimate that to find the product, what I would do is I'd look at estimating the 375. The single multiplier would stay the same. I don't need to do an estimate for that unless I'm trying to do easy mental math. But in this case, I'd be looking at estimating the 375. If it does not tell me where to estimate to, I estimate to the largest place column, or I round to the largest place column. In this case, the largest place column is the hundreds column. And what I would need to do is look to the right of the rounding digit. 0 to 4, stay on the floor. 5 to 9, climb the vine. 7 is in the 5 to 9 category, so it means this is going to climb, making that a 4. Everything else zeroes out. We could also think of that on a number line, and if I were to put 375 on a number line, I know it's either going to stay on the floor at 300 or climb up to 400. So when I do my number line, and what's my in between 300 and 400? Well, 350. So if I had to plot the 375, I know it's more than 350, and therefore my number needs to round up. It's closer to 400 than it is to 300. Okay, so basically I could estimate this at 400 and say 400 times 6. We already know 6 times 0 is 0 times 0, 0. 4 times 6, 24. 2,400 is fairly close to 2,250. So then you can ask yourself, is that reasonable? And yeah, I'd say that's fairly reasonable. Okay, so if it asks you to find the product, and then it asks you to estimate to check that your answer is reasonable, I'm looking for the full algorithm as well as your rounded estimate. Okay? Next question. What is the greatest common factor of 24 and 36? Well, we know to find the GCF, greatest common factor, we're looking for the factors that these two numbers have in common. So we always know that there's two ways that we can list all the factors. I like to keep things nice and organized, so I try and go in order using my divisibility rules. I know that one factor pair of any product is always 1 times itself. Okay? Then I can look at my number and go down my divisibility rules. Is 24 an even number? Yes, it is. Therefore, it's divisible by 2. 24 divided by 2 is the same as 2 times 12. Keep going down my divisibility rules. I know that a number is divisible by 3 if I can add the digits together, and that number is divisible by 3. So 2 plus 4 equals 6. Therefore, I know 6 is divisible by 3, and this number will also be divisible by 3. So 24 divided by 3 would give me 8, which is the same as 3 times 8. So there's my factor pairs. But there's actually more. I happen to know that 4 divides into 24, and 4 times 6 equals 24. So these are all my factor pairs of 24, and if I had to list them, I would need to list them out from least to greatest, and I would go in order. 1, 2, 3, 4, 6, 8, 12, and 24 are all the factors of 24. But I'm looking for the greatest common factor between 24 and 36. So at this point, another way that we could solve for the factors of 36 would be to do a factor rainbow. You guys have done lots of this, right? So we know one factor pair for any number is always 1 times itself. So 36. This is an even number, so I know it's divisible by 2. And 2 times 18 gives me 36. If I add these two digits, 3 plus 6 together gives me 9. And 9 is divisible by 3. Therefore, I know that 36 will be divisible by 3. All of these little clues and hints to help us divide. So 3 times 12 gives me 36. is divisible by 4 just because I know my math facts. But if the last 2 digits are divisible by 4, so if 36 together is divisible by 4, then the whole number is divisible by 4, in which case it is 4 times 9. There's one more set of factors, and I know that 6 times 6 also equals 36. So if I had to list the factors of 36, I would put them in order. 1, 2, 3, 4, 6. I don't write 6 twice because it's just one factor. 9, 12, 18, and 36. So now to get back to the greatest common factor, I'm looking for what factors they have in common. Here's my list of 24, the factors of 24, and all numbers will have 1 in common, so we actually don't count that when we're trying to find factors. They both have 2 in common, they both have 3 in common, 4 in common, 6 in common. They do not both have 8 or 9 in common, they both have 12 in common. And that would be it for their commons. What's the greatest common factor? Well, the largest common factor is 12. So I could say that the greatest common factor between 24 and 36 is 12. Again, factor out whatever makes life easier for you. I think the rainbow is nice because it keeps everything in order. Okay, doing good so far, nerdy Nawg-Dawgs. Let's keep going. Find 2 prime numbers between 42 and 50. This is similar to a question on the test. Well, guess what, nerdy Nawg-Dawgs? There is, of course, a helper tool in the classroom, and that is my prime number chart. You may use that. Otherwise, if I'm looking at 42 and I'm going to list all the numbers up until 50, I can just go ahead and find out. Remember, the definition of prime is that the only factors in a prime number are 1 and the number itself. So 42, we know we could do 6 times 7. It's an even number, so I know it's divisible by 2. I could always do 1 times 42. But let's look at 43. We know it's divisible by 3 if we add the numbers together, and the sum is divisible by 3. So 4 plus 3 equals 7, and 7 is not divisible by 3. This is, in fact, a prime number. The only factors I can find to make 43 are 1 times 43. Then I would look at 44. Well, 44 I know instantly is a double, so 11 times 4 is going to make 44. And of course, there's always 1 times 44. So this is a composite number. It will not work. However, 43 is a prime. Then I could keep looking. 45, I already know from my math facts that 9 times 9 times 5, oh my goodness, will get me 45. I also know 1 times 45. So this is a composite number. So you keep going down through all the numbers leading up to 50 and find the prime numbers. Or you use the tool on the wall and identify which numbers in between 42 and 50 are prime. Please make sure you write clearly. Okay, moving on. What is the least common multiple of 4 and 12? Do not get our multiples confused with factors. Make sure you're reading the instructions. We know that we can find multiples in a couple different ways. We can skip count. We also know that we can test for whether a number is a multiple of another number by dividing the number by your number in question. So for instance, what is the least common multiple of 4 and 12? Well, I could skip count. 4, 8, 12, 16, 20, 24. Then I could do the same for 12. Multiples of 12, 12, 24, 36. Oh, but I already see the smallest or the least common multiple. And so 12 and 12 is going to be the least that they have in common. And we would write that as the LCM equals 12.